Good afternoon, everyone. Gave you a shock. Thank you very much for coming. Some of you come quite a long distance to be here. This is quite a while since the last Temple Chevallier lecture. I hope the time to the next one is going to be slightly shorter. But it's my pleasure to greet Martin Ward, who will be giving the lecture, and Paula, as head of department, has agreed to give a short introduction.
I'm mic'd up. Hello, lovely to see you all, and welcome to this somewhat occasional lecture series. My name is Paula Chadwick. I have the joy of being head of the Department of Physics, at least everybody tells me it's a joy. So I'm going to give you a quick introduction both to Temple Chevallier and also to this evening's speaker. So Temple Chevallier was born in Suffolk in 1794. He went to Pembroke College in Cambridge, where he was second wrangler in mathematics, and he became a fellow both of Pembroke and later of Catherine Hall. He was ordained into the Church of England in 1820, and while he was at Cambridge, he held the post of Hulsian Lecturer in Divinity. He published 2 books, one of which, on the proofs of divine power and wisdom derived from the study of astronomy, was the subject of the Temple Chevallier lecture for 2005. In 1835, Chevallier moved north to join the fledgling University of Durham as Professor of Mathematics. He also became incumbent of the parish of Esh, which happens to be where I live, and where his wife and son are buried. There, he founded the village school, and he also renovated the parish church. In 1841, he added the posts of Professor of Astronomy and Reader in Hebrew to his CV. If that wasn't already enough, he then became the first registrar of the university. I'm beginning to think if they were trying to save staff costs even then, actually. However, what really annoyed him for the rest of his life, was that he never ever held the chair of divinity, which was the one he really wanted. Despite all these responsibilities, he devoted much of his time to the study of both meteorology and astronomy, including founding the observatory on Potter's Bank in 1842, of which I think we're going to hear more. He remained in charge of the observatory until his retirement in 1871, and, an innovation at the time, employed undergraduates to help with scientific projects, I think because they couldn't afford anybody else. He was a great supporter of science and university education, founding both a Department of Physics and a School for Mining and Engineering. In the year he retired, he helped found Armstrong College, later to become the University of Newcastle, of course. He died in 1873, following an earlier stroke, and has a lunar crater named after him. Now, like Chevallier, this evening's speaker is a man from the South who answered the siren call of the North to join us in Durham. He was born in a clinic on the Meteor Drive in Southend-on-Sea, thereby clearly setting his future career. After education at Imperial College and the University of Sussex, he also held positions at Cambridge. Their parallels with Chevallier stop, since as far as I know he wasn't ordained while at Cambridge, no. After posts at Washington University, the Royal Greenwich Observatory, Oxford and Leicester Universities, he joined us in 2004 as Temple Chevallier Professor of Astronomy and was head of department from 2009 to 2014. Sympathy, Martin. He has served on very many committees, both nationally and internationally, including as Vice President of the Royal Astronomical Society, and he is presently Scientific Editor of monthly notices of the Royal Astronomical Society. His scientific interests are centred on active galactic nuclei, truly apocalyptic bodies with supermassive black holes that are consuming material from their host galaxies and spewing some of it out as relativistic jet. His lecture tonight, as you can see, is entitled The End is Not Yet Nigh, the Ultimate Fate of the Universe, undoubtedly a topic that would have interested Chevallier himself. So let's welcome Professor Martin Ward.
Thank you very much, Paula. I'm just going to set the clock here. What I always do is I set it to midnight because it's easy to know then how much I've overrun rather than having to calculate plus and minus. So just give me a second here. And we can start. Here we are, midnight it is. And also, I'm very old school, so I like to have backups. I don't trust this technology business. So I brought my timer here, which actually runs out after about half an hour, but it gives me a prompt of where the sands of time are running out. So as Paula said, thank you very much for the kind words. I was born in Meteor Road, was it Road Drive or something like that? And to my regret, of course, it was not Meteorite Drive, because that actually lands on Earth, whereas meteors burn up in the atmosphere. But, you know, you can't win them all, and I didn't have much say in the matter at the time. So this is a much delayed lecture. I can blame COVID for maybe 3, perhaps at a stretch 4 years. The other 7 years, various reasons, you know, this and that comes up and things get delayed and so on. But finally we're there, and this is it, as they say. So I hope you can all see this. Well, that's the poster. So it's going to be much about Durham. This is more or less the view from my house on South Street, not quite. And Durham features greatly in the career times of Temple Chevallier. So the talk's in 3 parts. Now, luckily, Paula has preempted the first part, but I'll zoom through it. Just 1 or 2 things she might have missed, but I will not dwell on it because it's very good that she did this, because the other 2 parts, eschatology. Now, I'm guessing that probably a minority of people in the room know what eschatology is. It's a lovely word, isn't it? I know that the clerics know what it is, and the theologians know what it is, and maybe some of the Radio 4 listeners might know what it is. But I'll explain later what it is. That's the middle. And then the end, a bit of a pun there, the end of the lecture will be what cosmologists have to say about the end. So, a couple of disclaimers. This is not for legal reasons, it's just that I want to make it clear that I'm not a theologian, I'm a very simple-minded astrophysicist. And I will make no value judgments on any of the scenarios related to the end times in various religions. I will draw no conclusions on how similar any of these scenarios might be perceived in relation to current scientific models and predictions. I leave that to you to do. And finally, I apologise in advance for any misrepresentations contained in the eschatology part. I'm a complete novice, although having dabbled in it now, I'm very keen to do a degree if I can be advised on one that's available. It's a fascinating subject. Okay, first things first, let's get the name right, which Alistair, I'm sure, I won't blame him for this, didn't get it right. The name rhymes with Cavalier. It is Chevallier and not Chevalier. People of a certain age may be aware of Maurice Chevalier, the chanteur in France. It isn't, and there's a reason for this, which I'll come to in just a moment. So just think of Cavalier. It's Chevalier. Why would he, or the family, I should say, not wish to be known by the more obvious Chevalier, which of course means knight? Well, it's because the family moved from France in 1728, then to Suffolk, sorry, it moved to Guernsey first in the Channel Isles, and then to Suffolk in 1728. And they moved from France because they were Huguenots. And in the 17th century, there was quite a bit of unpleasantness between the French Protestants and the Catholics. And the Huguenots were more or less expelled from France and became a brain drain to other countries. And we benefited from this in terms of that family. And I don't know, because there's no one around to ask, but I suspect the family wished to be separated from their French heritage. And hence, Chevalier was replaced by Chevalier. By Chevalier, I'm sorry. So this is a mix-up, isn't it? Chevalier was replaced by Chevalier, as in cavalier. Right. I don't need to go in the rest of it because it's already been mentioned. One thing I don't think was mentioned is that he founded the first taught course in civil engineering here in Durham. I don't know the exact year, but obviously during the time he was here. Probably as a result of the mining that went on during that period, one suspects. Unfortunately, it failed after quite a short period of time due to lack of students. and I suppose there's a moral there, but he was the first one to at least think about having a course in civil engineering. So let's put his life in some historical context, and this is obviously a random selection of things. So the first thing, which is a little bit of a cheat, is the Reform Act of 1832, because he didn't come here to 1834, and I'm really putting his time in Durham in context rather than his whole life. But that was a very big thing, and I'm sure he would have had thoughts about this, and I don't know, but he may have written about it, but I haven't seen any of that material. 1848 was the year of revolutions across Europe against monarchies. I think one can assume that as an Anglican priest he was probably not greatly in favour of revolutions against monarchies, particularly British monarchy, but we managed not to be involved in 1838. Then the Crimean War, a big event made famous by the infamous, I should say, Charge of the Light Brigade and by Florence Nightingale. The Crimean War was a big event, and the Durham Light Infantry was involved in that war, and it is possible that he had connections with some of the soldiers. Again, I don't know, but that was an overlap of that period. Perhaps more importantly, certainly in terms of his theological thinking, Darwin published his book on the origin of species in 1859, and I'm sure no theologian cleric in the whole country can have not have had a view on this. I'll mention very briefly his view in a later slide. The American Civil War probably didn't have much of an impact. If he'd been a priest further down in Lancashire, it would have had a major impact, because during that period the Confederacy could not export their cotton to our country, and hence the cotton industry collapsed. But that was in Lancashire, not even Yorkshire, so probably he wasn't greatly affected by this. Other things that will have occurred, the birth of modern Italy. Don't know whether he had any interest in that. He will have known about it. And towards the end of his life, shortly or more or less the same time as his stroke, the German Empire was founded. And, well, I don't suppose he foresaw the implications of this at the time, but he would have been alive and knowledgeable of that event. So, Temple Chevallier was the director of Durham University, Durham Observatory, for a long period. It's on Potters Bank, 1842-1871. You see here a contemporary of when it was built, picture of the observatory in the lithograph, the sketch, and now what it is, more or less, taken a few years ago now. Now, the observatory is a very interesting building. It was the first building to be commissioned by the newly established Durham University. There's a lot of debate about Durham. Is it the third university in England? Carefully said, England. I think you can probably guess the other ones. There is a bit of a debate with Manchester and University College London as a result of royal charters and some details. But anyway, Durham has a claim to this. So it's an iconic building, the first building to be commissioned by the people who ran Durham University. It's a lovely building. I don't want to harp on too much about it, but for about 15 years I've been trying to think of a use for it that was something other than piano practice and snooker, which is what it's currently used for. Now, I'm not deriding the fact that students should have access to a piano and a snooker table, but I'm not sure that's the best use of the observatory. I think it could be used for something perhaps more in keeping with the heritage. There are problems, but I'm interested in solutions, not problems. Enough of that. So this is the only picture of me, perhaps one too many, underneath the portrait of Temple Chevallier in the Great Hall of the castle, looking down austerely on me with the white beard. I don't think I look very much like him, but there's time, isn't there? I could still grow a beard. So there's another picture of the observatory there, perhaps a prettier picture than the previous one. And something rather interesting is the observers who, I think it's observers, who helped Chevallier in his work, because he was a busy person, what with all this registrar, Esh-winning at church and so on, and everything else he did, registrar. Of course, in those days, the registrar of the university probably wasn't quite as arduous as now, because I don't know the exact numbers, but I'm rather suspecting the number of students was perhaps not quite making it into triple figures. So it probably wasn't as arduous. Anyway, the people listed there, and I won't go through them all, of course, because it would be a bit boring, but one of them in particular, Carrington. And I want to mention Carrington. I know it's a lecture about Chevallier, but Carrington was a very interesting person. He actually studied sunspots, and Chevallier was the first British astronomer to institute regular observations of sunspots, but Carrington was perhaps a bit more interested, had more time than Chevallier, to study the differential rotation of the sun, the fact that the equatorial part and the upper bit, the polar regions, don't rotate at the same speed because the sun is not a solid body. We all know that, it's a gas ball. But this was a very interesting thing which Carrington studied. But more than that, Carrington was responsible for studying solar events, flares on the sun. And you see here on the right-hand side a loop picture of a solar flare. Why are these important? Well, because just a week or so ago, who saw the aurora? I'm sure a bunch of people would have seen the aurora. That's what causes the aurora, these energetic particles that are accelerated from these giant flare events, travel to the Earth, and then interact with our magnetic field and are funneled down towards the poles, but we can see the effects, the glowing light, a bit like a fluorescent tube, as the aurora. So Carrington did a lot of work on this, and in 1859 there was a massive solar flare. And if this happened today, it's actually on the risk register of the government, along with being hit by asteroids and pandemics, etc. If there was a Carrington event of a similar magnitude today, it would be very, very bad news for communication satellites, power lines, and even switching things off doesn't help because of induction. Physicists will know what I mean by induction. And what happened in 1859 was there were no mobile phones, fortunately, and all they had was Morse code. All they had was telegraphs. And the telegraph system was fried because of the induction caused by this effect of the energetic particles. And many of the communications were disrupted until they could repair these things. So if the Carrington event happened now, it would be very bad, and even if we had notice of it, it would still be very bad. So some final remarks about Temple. He did not see a conflict between religion and science, as some people see today. Interestingly, completely an aside here, the term scientist was not used until 1833, which is more or less the time that he came to Durham. He regarded science as a gift from God. He also did not think that Darwin's theory of evolution was in conflict with this. He thought that it was something that should be studied and that it was all part of the glory of God. So unlike many clerics of the time who thought that Darwin's theory of evolution in some way disproved God, or at least was in opposite sides, he was not one of those. He wrote, as Paula has said, the proofs of divine power, and asked the questions, the fundamental questions of where did the laws of nature come from. Perhaps this might be thought of as an early version of the anthropic principle. Some of the scientists and maybe others in the audience know what we mean by that. And that is, the universe is as it is, because if it was not as it is, we wouldn't be here to look at it. And in a sense, that's what he was asking. Where did these fundamental laws come from? So you could think of it as the great design, although that's a simplistic version of his ideas. If you want to look at this in more detail, his theological thoughts, then I offer an excellent reference by David Wilkinson, reference is given here, which focuses most on his theological leanings rather than his scientific. I'll take these off. By the way, the reason I'm wearing these, it's boring, but I had a cataract operation and this is to balance the light, but I'm realising it's not working too well with the screen. Anyway, it'll all be solved when I have the other eye done, eventually. So, Temple Chevalier's legacy remains to be seen on the moon. Those of you who are amateur astronomers with a small telescope, of which I am not an amateur astronomer, I came into physics, to astronomy via physics. I did have a small telescope when I was pre-teen. I took it out into the garden a few times, and I looked at the moon, and that was really interesting. I looked at the rings of Saturn, that was interesting. The moons of Jupiter, also interesting. I looked at stars, and I thought, wait a minute, you've seen one star, you've seen them all. You know, what else is there more to do? So I'm sure amateur astronomers will disagree, particularly now, because things are much more powerful. But I stopped being an amateur astronomer at that point. If you are an amateur astronomer, you can find his crater by looking for the Atlas crater, which is quite big and easy to find, and then look down a bit and you'll see a series of craters. One big one and some little ones. And what happened was, when the main Chevallier crater was given, the name was given to the crater, they didn't know about the little tiny ones. But as telescopes got bigger and bigger, they then discovered the smaller and smaller craters. And rather than give them random names of, you know, slightly less famous astronomers and scientists, they called them after the big crater and gave them A, B, C, D, etc. So that's why he has a series of smaller craters named after him. Interestingly, another one of his observers, can't recall which name it was exactly right now, but has a larger crater named after him because he became an FRS, and I guess that gets you a larger crater. Now, moving right along then, eschatology, the study of end times or the end of time. I will say right away that I'm not an expert in this, and what I'm going to say is the briefest commentary on what various religions think of as being the end of time or end times. Also, I'm going to say nothing about what happens after the end time, because there's a very big building not far from here filled with people who'll be happy to answer that question. It's way beyond my pay grade. So I'm only talking about what happens at the end times and not after. So Christianity, of course, because of our position in the world, etc., we probably know a lot more about the Christian version, although perhaps not the authentic details of it, through various things like the Book of Revelation, and of course through popular movies such as The Omen and so on. But I don't think that's a very good representation of the end times. Anyway, we're familiar with this. And the other thing which perhaps not quite so familiar, the final battle in the Christian idea of the end of times is the Battle of Armageddon. And I'm not sure everyone knows this, but there is a place called Armageddon, which is in Israel, and there's a field with ruins, and shown here in the picture. And this is only one step towards the coming of the Messiah, the second coming in the case of Christianity. Interestingly, many of these religions, which I'll mention just a few of the major ones in this talk, the sun and other things, it's often said that the earth will be consumed by fire. And so the sun is often referred to as the source that will absorb the earth and create an inferno which will destroy it. Not just, this is a quote from the Bible, but I don't have the actual reference. So now let's think about Judaism. So they tend to call this the end of days. And the final battle in this case is in Jerusalem, after the gathering together of the diaspora and the culminating in the coming of the Messiah. I notice in my limited research on this subject, there is a thing called the Book of Splendor, which is Jewish mystical thought. It's not the original book which the Jews refer to, their Bible, the Torah, but nevertheless it has very interesting ideas. So I have not read the book, including the persistence of creation. And so their details, perhaps of the end towards the end of time, are contained in this, as well as in the Torah. Now turning to Buddhism, well, like all these things, it's very complicated. There are different versions of Buddhism. there's Orthodox, there's Chinese Buddhism, and all I'm going to mention is just one version, and that is, it is foretold that the writings of Buddha will be forgotten after about 5,000 years, and a new age will begin with the appearance of a new Buddha. And as you probably know, the idea in Buddhism is that there is reincarnation, and it goes in a circle, and depending on one's life, one comes back in various other forms. The aim, of course, is eventually to stop this cycle, this wheel of life, that's the picture here on the right-hand side, and to reach nirvana. And so the end times for Buddhism would be the destruction of the world in stages, called the seven suns. The sixth sun will bake the earth as a potter bakes a pot. Again, fire consuming the earth, although it's the seventh sun which actually completely destroys the earth in an inferno. So now Hindu, now that's an interesting, well they're all interesting, but this one perhaps interesting because it doesn't follow a linear line in eschatology. It is cyclic, or is it cyclic? So time consists of these kalpas, which starts with complete purity and then ends with decline and corruption. The cycle will repeat again and again until the greater cycle under Brahma is reached, when it returns to a singularity. As I say, I wouldn't make too much of these overlaps with cosmology, but it's a mathematical term. It returns to a singularity and a new universe is born. So in a way this is different from the other versions of the end times because it is cyclical. The picture on the right is just something I find very interesting. It doesn't refer particularly to the end times, but Hindu cosmology has the idea that the world is supported by elephants on the back of a giant turtle. And there's a joke which my former boss, Martin Rees, used to tell. I'm not sure where he got it from, probably from somebody else. And that is, somebody is supposed to have asked, "Professor, what's below the turtle?" To which he says, "Oh, that's easy. Its turtle's all the way down." So finally then, Norse legends. Again, I'm not giving a complete rendition of all religions. For example, I'm not going to talk about the South American religions, about the calendar finishing and the world ending. It didn't end, as we know. So this is my last delving into this subject. Norse legends go way, way back, of course, starting in Scandinavia and then being co-opted by what became Germany. The Scandinavian version is called Ragnarök, and this is what Icelandic mythology and Scandinavian mythology believed. The German version is Götterdämmerung, perhaps more familiar. Twilight of the Gods is the translation. So the sign, one of the signs of the coming of the end of the world, is when the hellhound, shown here on the right, guardian of the underworld, breaks loose from the chains and escapes from the pit. Very poetic. So maybe in Iceland they're thinking that's about to happen. I'm not sure what the latest is on their volcano, but I'm sure they'll survive. However, it has a happy ending because in the end 2 humans survive and repopulate the earth. Interesting that 2 humans survive. A bit of a resonance there with other religions. So now moving on, that's now towards the eschatology finished, and now this is my third part, which is to do with the universe and the earth. So the end of the world, as we know it, the song goes, we shouldn't conflate this with the extinction of human life and with the physical destruction of our planet, or the universe. I mean, the universe obviously is what my final part of the talk will be about. So let's think about the earth for the time being. There are various ways on offer to destroy the earth, or at least damage it very severely. Asteroids, I think everybody knows that was quite effective on the dinosaurs 65 million years ago. And from one of the sources, I'm not sure which, I got some information on the chances of this happening, and I'm sure there are lots of other versions of this and a range of possibilities, so this is only one. It is based on science. One possibility is 1 in a million years in the next 100 years. So not very likely, But that's a major impact, of course. There are lots of minor impacts. So this is a major species-destroying asteroid impact. Not one of the ones that you might see on the right-hand side, which is the Arizona Barringer meteor crater, which was about 6,000 years ago. That's what we could call the city-destroying asteroid. So it would not destroy civilization, but it would certainly destroy big cities. So that number above is for a species-destroying asteroid impact. Now, things have moved on, of course, because the dinosaurs didn't have rockets or radio telescopes or proper telescopes. Now we could see an asteroid coming, and there's a lot of work being done, not just with professionals, even amateurs do this, searching for asteroids at an early stage so that we could, in principle, do something about it if we saw one coming. Every now and again, the press gets hold of a story about an asteroid is about to hit the Earth or will hit the Earth in 20 years, 50 years. What this usually means, in practice, is that we have a probability circle that the asteroid could impact the Earth. And that circle can be very big, but as the asteroid gets nearer and nearer, the circle is refined because the orbit is refined, and then the chances get less and less and less. And so this happens time and time again. It's sort of, oh, it's going to happen in 100 years. Oh, it's 1,000,000 to 1 in 100 years. So if you see these headlines, you have to look a little bit in more depth. And in any case, we could in principle do something about it. I don't know whether you follow the space news, but there have been several efforts, successful efforts, to return samples from asteroids. And one of the reasons for doing this is, of course, the origin of life and what is the asteroid made of in terms of organic material. That's very important, very interesting. The other reason is they want to know more details about the mineralogy of the asteroid. And if they know about this, they could, in principle, think about how we could deflect it, either with bombs, missiles, or possibly just by shining lasers at it. If you were to concentrate in a certain part, maybe you could spray it white. That would be good, because that would push it harder. So these are all interesting things. Anyway, asteroid threat, it exists. It's possible. Other threats, supernovae, well, that's pretty unlikely. We know this is based on real astrophysics, so this isn't really speculation. We know about the rate of supernovae that explode. We know the distribution of stars in our local neighbourhood. A supernova explodes into a sphere, what we scientists call 4 pi, so it's the whole sphere. And so we can calculate the effect of a nearby supernova on our atmosphere. And if it was very nearby, it would be very bad, because it would destroy the atmosphere, or at least temporarily would heat it up, and there would be devastating effects. It's not that likely, but the other thing, gamma ray bursts, something a bit different, and that is where two neutron stars, very dense stars, come together and cause a black hole. They merge, and they cause a jet, a very focused jet. Another version of neutron stars is where a big massive star contracts. The same thing happens, you get jets. But you have to be pointed at these jets for anything to happen. And it's very unlikely, because if you think of a lighthouse only illuminates, well, it spins, so it illuminates a ring. But if it didn't spin and just sat there as a static lighthouse, it would only illuminate a very narrow path of light. And so in these gamma ray bursts, you'd have to be in line with that narrow burst of light. So it's not very likely. What does it say here? 1 in 15 in the next 100 million years. Well, probably other things to worry about then. Nuclear war, well, what can one say? I mean, geopolitics keeps changing. A decade ago, which is why I found the information, it was 1 in 30 in the next 10 years. I have no idea what it is now. It must be based on a massive range of assumptions. Finally then, I think this is the final one, on offer is a pandemic. So I've looked into this a little bit, and I cannot find accurate numbers for COVID, because there are no accurate numbers for people who died in China and possibly India as well. So it is almost certain, I would say virtually certain, that it killed less than 1% of the global population, probably 0.1%, but I'm being very conservative in saying 1%. The Black Death, famous Black Death, 14th century, Probably, again, who knows how many in China, but we know about Europe at least. Probably killed between a quarter and a third of the world population. Well, that's pretty bad, but there were some positives if you weren't one who died, and that is the Black Death, of course, was the end of serfdom, because the labour market meant that you couldn't have serfs anymore. So it did the serfs, the ones that survived, some good. So let's think of the worst possible scenario. It's very unlikely that any pandemic could kill more than 99% of the global population. And because we know the global population fairly accurately, that will still leave 80 million survivors. Now, those survivors would be scattered all over the place, some places a few more as a fraction than others. But 80 million is about the number of people in the whole world in the time of ancient Greece, 1000 to 500 BC. So I don't think that would be the end of human life. Maybe the end of civilization until something emerged, but not the end of human species, at least. So let's move on now. Let's now move on to destruction of the earth from the destruction of humankind. So I think I may have mentioned this, that when the sun becomes a red giant in about 6 billion years, the result will be the ultimate global warming. So this will be plus 3,000 degrees, not 1.5 degrees, but it's a long, long way in the future. But there's not much we can do about it. It's not a question of not using oil. The sun is going to become a red giant, and that's it. That's physics. But it's a long, long way off. So we have perhaps a good idea of how the Earth will end, inevitably. What about the universe? So this is Alpha and Omega. So, of course, the title of my talk is The Ultimate Fate of the Universe, but we have to know a bit about the beginning to know something about the end. So let's consider the universe. So t equals 0, and I'm afraid, at risk of repeating myself, if you want to ask me what's before t equals 0, there's a big building not far from here, go and ask them. So the Big Bang, or perhaps a more descriptive phase, could be everything everywhere all at once. I haven't seen the movie, but it's quite appropriate, I think. What is the universe made of? This is a coloured version of a Middle Ages, wouldn't be called scientist, of course, but natural philosopher, looking through the crystal sphere at what was thought to be a rather mechanical universe, where everything was set in motion by the Creator, and it all worked a bit like clockwork. It was all in perfect order. So what is it made of? Stuff. Okay, well that's perhaps a bit too basic, although obviously true. So unpacking that a bit, what is the universe made of? Well, we do understand quite a lot more than we did a century ago, but the bad news is we are very unclear about the nature of what the universe is made of. So as people in the audience know better than I, because they study this more than I do. For my day job, I work on black holes, and they're pretty standard, easy things. But there are people here in this room that study dark matter and, to a lesser extent, perhaps dark energy. But got ahead of myself. So normal matter, which is everything we know about, that's us, stars, galaxies, even neutrinos, which are pretty weird things, heavy elements which making up us, and everything in the interstellar medium, all adds up to about 5%. So what's the rest of the 95%? Well, I'm not saying we got this exactly right to 1%, but it's close. Dark matter, 21%. Dark energy, 74%. And if you do the maths, that's about right. Actually, it's the dark energy which is the killer towards the end of my talk when I come to the fate of the universe. But let's have a talk about dark matter for a moment. I have another talk which I call The Anatomy of Darkness, and that features three things: black holes, dark matter, dark energy. As I said, black holes are very interesting. It's what I do most of my time for research, but I'm not going to talk about those because they almost certainly exist, well, as close as we can tell, because we can measure the gravitational field around stars, and it more or less has to be a black hole. Dark matter, on the other hand, this was my comment on, I think this comes from, which one is this? It's not the Inferno, is it? Which one? Anyone want to shout out? It's the other one. I'll think of it in a minute. The Inferno is the picture, one of the pictures from the book. So, black holes, not talking about that. Dark matter, the role of the Large Hadron Collider. It's quite interesting that in order to study the tiniest things you can imagine, subatomic particles, you have to build the biggest thing we've ever built to study them. It's a bit like the same thing with studying galaxies and distant things. You've got to build really big things or put them in space. So why do I mention this? Well, this is another view of the Hadron Collider. Just down there in the middle bottom, you can see a tiny human being. So all the rest of this stuff is associated with accelerating particles. And the basic idea is rather simple. You just bash them together. So as they say in The Hitchhiker's Guide to the Galaxy, keep bashing the rocks together. And what they do in the LHC is they bash the particles together so hard that they fragment and they form lots of other particles, which is where the Higgs boson, how the Higgs boson was discovered. So it might discover mini black holes and it might discover dark matter. But unless I missed a press release, please shout out if I did, neither of these have happened yet. So we're still waiting. By the way, this track here is a track of what you get when you smash things together. And then people spend their lives with supercomputers and deep thought to try and interpret what these fragments are telling us. And is there a fragment we didn't expect? And if there is that another subatomic particle? So there's a lot of work to be done with these things, and it's ongoing. So before I get to that, so dark matter, we don't know what it is. It's probably some kind of subatomic particle, not the Higgs boson. And my colleagues in the Ogden Centre have been working on this for many years. No luck yet, but I think they're still hoping that they might eventually figure out what it is. So the timeline of the universe from t equals 0 until now. The question mark is basically, we cannot say what happened before time equals 0. We don't know much about what happened time in an infinitesimal amount of time after time equals 0. But after that, we have some information. And we have that through telescopes. And I want to mention telescopes because that is how we know about the beginning of the universe. So the finger of time is one way. Time marches on. And I like this little bit of poetry, which you'll have to excuse me for using, and that is, the moving finger writes, and having writ moves on, nor all your piety nor wit can call it back to cancel half a line, nor all your tears wash out a word of it. Very poetic. So the finger of time is one way. Einstein made this famous quote, distinction between past, present and future is only a stubbornly persistent illusion. However, I looked into this a little bit in the quotes, and I think this was something he was trying to console a relative who'd been bereaved, rather than a new theory of the universe. But it's often quoted, as many of Einstein's saying are, out of context. Where are we? So let's just, for a moment, think about time machines. And we do have time machines, but let me just test you. Does anyone know what this one is? H.G. Wells, yes, of course, not from the book, from the movie, 1950s movie. Quite a good movie, actually. There's Time Machine, yes. This one, not much of a prize for the DeLorean, Back to the Future. And even less of a prize for this one, Doctor Who. So, machines. So, okay, but telescopes are one-way time machines. They only go backwards, they cannot go forwards. Although we have computers, as I'll come to in a minute, with sophisticated computer models that can go forward, but that's coming later. So looking back in time to the nearest star, it's taken the light, because light has a finite velocity, 4.5 years to reach us. So by my calculation, if you look at Alpha Centauri, I think you'd have to be in the southern hemisphere to look at it. There are many other stars available, but I'm choosing this because it's the nearest star. You're seeing the light that left Alpha Centauri before COVID. So that's, you can imagine what you were doing just about before COVID. Let's look further back, about 1,344 years, which I think by my calculation, unless I'm a year out because it might be an old slide, that's to the year 679 AD. Anyone? Well, lots of things happened, I expect, but one thing that happened, if you look at the Orion Nebula, you're seeing light that left the Orion Nebula that length of time ago. Of course, you don't see this with a normal telescope. With a little telescope, you see a fuzzy blob. But if you have the Hubble or some really big telescope on the ground, you would see something beautiful, just like this. So what happened then? The Lindisfarne Gospels. So that's quite a long time ago, isn't it? You're seeing the light that left the Orion Nebula at the time of the Lindisfarne Gospels. So I've only got one more of these, I think. Let's push it and look back 2.5 million years, light years, the emergence of Homo habilis. So this is Andromeda, Messier 31 if you prefer, the Andromeda Nebula, which is a galaxy. You will not see this with the naked eye. In fact, you'd be very lucky to see it this near the moon. The only reason I show this is because the scale is right. If you had a very sensitive telescope with CCDs, that's cameras, that could photograph it, you would see something that was that big on the sky compared with the size of the moon. So it's actually many times the size of the moon, although you would not see it with your own eye or with a small telescope. So you can see with your eyes, if my eyes not, because, by the way, that's why I'm wearing these glasses, because of the cataract. Anyway, if you had good eyesight, you would be able to see a fuzzy blob that was 2.5 million years in coming to you, the light therefrom. And that would be the emergence of Homo habilis. So finally, the ultimate look back. We can't see the origin of the Big Bang 13.7 billion years ago. Can we see back to the beginning? No. But we can almost listen back to the beginning of the universe. And this is the cosmic microwave background. So this is not a talk about astronomy, but very briefly, what happened was, in the very early universe, 300,000 years, maybe 400,000, an exact number, not that relevant, after the Big Bang, the photons, the light particles, and the particles, the atoms, the nuclei, were interacting with each other. The photons were getting absorbed and then re-radiated and absorbed, and they couldn't escape. But after a certain period of time, due to the expansion of the universe, they could escape. And at that point, we can actually see by the microwave background, the structure of the universe. Now, interestingly, it's the microwave, which many of you will know, of course, you have an oven. It's quite a long wavelength, and it's quite cool by standards. It's about 2.7 degrees, if it was a thermal thing. But actually, when it was originally happening, it was about 3,000 degrees. But the redshift, the expansion of the universe, has redshifted the 3,000 degree wavelength equivalent to 2.7 degrees wavelength. That's why we call it the microwave background. Anyway, a bit of astronomy thrown in for free. Sorry, I wanted to say this. Yes, so we can't see it, but we can hear a bit of it, and no expense spared. This is a shortwave radio. You can hear this hiss. Now, just a slight digression. So shortwave, I don't suppose many of you have a shortwave radio now, because it went out of fashion probably when people stopped broadcasting on it, and we have the internet now. Very popular in the Second World War for communicating with the resistance. And those of you interested in history, this might be familiar. Ici Londres, Jacques a deux éléphants. Je répète, Jacques a deux éléphants. And this is how we communicated with the French resistance. That meant blow up the troop train. So that shortwave was very useful, but we don't have it much now. What's the relevance to this, back at the real world? So the relevance is that hiss is made up of many, many different things. Flashes of lightning far, far away, noise from trucks, from unsuppressed spark plugs, all sorts of things. But some small fraction of that hiss is in fact the microwave background. So you're listening to the relics of the Big Bang in some small fraction, if you have a shortwave radio. Right, that was the end of that. So, looking into the future. So we have the past, and we think we have a reasonable idea how things started. I mean, the Big Bang is generally accepted. Interestingly, the words Big Bang were coined by Fred Hoyle as an insult for the cosmologists who believed in this sort of thing. But now, of course, it's an accepted term. But he would perhaps not be too happy that we now use his insult to actually strengthen our idea about how the universe began. What about the future of the universe? Well, we can't look into the future, we can guess, but supercomputers can be trained using the laws of physics to extrapolate forward using lots of physical laws which we think are universal, and things like dark energy and now dark matter and the star formation rate, quasars, which are another component of the universe. They can be trained to project forward and to see what the universe will look like in the very distant future. And we have experts here in the audience who do this for a living. And I believe, because I listen to Radio 4, that quite recently a refined model of this supercomputer has done a very good job in predicting what we actually see. So maybe we're getting closer to understanding. This is an old picture of the cosmic web, but it gives you a principal idea. So we start off then with a cosmic web of dark matter and galaxies that are forming, and they come together to form clusters of galaxies. Everything evolves, and eventually we end up with the universe that we now see. So that is the best way in which we can project forward. Back to basics now. It's been known since 1929. It's interesting that in the distant future, if civilization has a distant future, will 1929 be known for the Wall Street crash, or will it be known for the Hubble expansion of the universe? Not sure, but I think one is probably more important than the other. So the idea of the expansion of the universe is very simple, and I'm sorry, it's a bit of a toy picture this, but the idea is surface, of course, it's 4 dimensions. There's time and 3 space dimensions. But if you think of a balloon with lots of dots on the surface of the balloon, and you expand, you blow up the balloon, all those dots are going away from each other, every one. It's not as if there's a centre. There is no centre. In fact, if somebody says to you, where is the centre of the universe? The answer is you, because everything extrapolated back came from a singularity. So you are the centre of the universe. But as it expands, everything gets further away, and it gets faster. So the fate of the universe, and this is a relatively recent thing, about since 1999, I believe that's right, when a massive discovery was made, and that is dark energy, not to be confused with dark matter. Dark matter, believe it or not, is perhaps a more comprehensible thing, because we pretty much know it's there because of the way that galaxies rotate. There are various other reasons we know it's there. We just don't know what it is. So the dark matter is not so incomprehensible. Dark energy, on the other hand, is something which we only recently came across or detected. And it was done in the following way. Supernovae are exploding stars. And they're a certain type of exploding star. And when they explode, they release a certain amount of energy. And if you like, it's often referred to as a standard candle, a rather sort of old-fashioned term, but astronomers often use these old-fashioned terms. So they're a standard candle, and if you see one in the distant universe, and you know that it's so many watts, so much energy, you can work out by simple arithmetic, more or less the inverse square law, you can work out how far away it is. And so in 1999, it was discovered that these standard candles were telling us that the universe, far from slowing down from the expansion, as you might expect from an explosion, might eventually stop expanding and then start to contract. It was doing the opposite. It was speeding up with time. Completely strange and against common sense, although common sense, of course, is irrelevant, because what does common sense mean? Our brains are a certain size. Why should common sense work? But anyway, it went against the current theories that the universe was slowing down. So in the last 5 minutes or so, if there are going to be some questions, I come to the ultimate fate. So we have here 3 options. Well, not yet 3 options. This is what happens with time. So on the left-hand side is an early stage of the universe where the amount of matter is constant. That has not changed, because we don't believe, unlike Fred Hoyle and the steady state, that matter is created from nothing. Except, of course, you could say the Big Bang is something from nothing, but that's another thing. But we don't believe that within the universe matter is suddenly coming into existence. So there's a fixed amount of matter. And so that's what this big heavy weight is supposed to be, pulling the universe or slowing the expansion and eventually winning. This balloon thing is dark energy. Now, in the early universe, the dark energy fraction of the universe was smaller than it is now. And as time went on, the dark energy, as the universe expanded, became more and more important. So although I said we don't create matter from nothing, the dark energy is becoming more powerful as the universe expands, which is really odd, but that's what we think. And so eventually, the dark energy will stop the matter from pulling itself back again to perhaps to another singularity, and will win. So here are the three fates, and which do you prefer? The big crunch was what we pretty much thought before 1999, and that is the universe would go on expanding until eventually, eons and eons in the future, it would eventually, gravity would then pull things back, and it could then collapse to a singularity, called the big crunch. Finely tuned universe is where it expands forever, but doesn't get faster and isn't accelerating, it just expands. And then there's the big rip, which is the expansion of the universe accelerates and dark energy wins. Well, I think I may have given the game away, actually. The end of all things at the moment, if we are right, which we may not be, the big rip wins. So here's the final few slides. What happens 6.5 billion years from now? The Earth is destroyed, first by the red giant. That's what happens to the Earth, but eventually the red giants collapse to a white dwarf. It doesn't become a supernova because the sun isn't heavy enough to explode and become a supernova. That's the fate of stars that are relatively small mass, that is. 10 to the 12 years, by the way, these are 10 with 12 zeros. So that's 10 to the 12 years. Star formation stops and galaxies fade. The light grows dim. So here's the life cycle of a star, starting from a nebula. So as I expect you all know, I have another lecture which goes into this, and I use the Joni Mitchell Woodstock song, We Are Stardust, because we are stardust. We are formed in supernovae, that's our heavy elements are formed in supernovae, dust of stars, which then become planets. Eventually, then, if it's an average star, it will become a white dwarf. If it's a bit heavier, it will either be a neutron star, famous pulsar, or even heavier still, it will become a black hole. That is the fate of stars. Different timescales, but that's how they will end up. So 10 to the 14 years, which is more zeros, darkness reigns, visible wavelengths cannot see anything, only stellar remnants remain. So all that remains are cinders. Brown dwarfs, white dwarfs have got cold. Black holes, of course, are black, so they exist, but nothing is visible. There is no light. 10 to the 15 years, planets detach themselves from their suns. This is because gravity is losing the battle against the dark energy, which is a negative force. So whereas gravity was holding things together, dark energy is pulling them apart. 10 to the 19 years, a few more zeros, stars escape from their host galaxies. The centre cannot hold, again a famous quote. And gravity is too weak to hold galaxies together. So all the stars and the fragments of stars in all these different types of galaxies, this is just a mosaic of all the different types of galaxies, will eventually disperse, and so there will be no structure of galaxies left. What next? We're getting close now. So 10 to the 36 years, and I bow to a particle physicist here. I just read this on some fairly reputable website. It is possible that the protons, that's a subatomic particle in the nucleus, will decay in that length of time, and then other particles, all particles, will decay into photons and other particles in 10 to the 43 years. Getting there. Where are we? Okay, so 10 to the 66 years, the last things to go are the black holes, because the black holes have the strongest gravity of anything, stronger than stars, stronger than holding stars within galaxies. So eventually Hawking radiation, which has not been detected, but it is plausible if we're right. This is all speculation, of course. None of this is proved. If they evaporate via Hawking radiation, then the black holes will eventually go, starting with the small ones, the stellar mass black holes, which are in binary systems often, and eventually, 10 to the 100 years, supermassive black holes will eventually evaporate into Hawking radiation. Now, we're finally there, and my time's almost up. So, what does this mean? So, just the last couple of slides. So, every photon, which is now all there is, because subatomic particles have turned into photons, everything has evaporated, is in its own island universe, its own event horizon in space and time. And at that point, time ends, because I'm not a philosopher, so I'd be interested to hear their view. If nothing can happen, does time have any meaning? So I think it's plausible to say at that point where nothing can interact with anything else, every photon is its own universe, unconnected with anything else, time ends. And another quote here, which is from a famous movie, Blade Runner, everything loses its identity and merges like tears in the rain. Or, if you prefer, quote from Shakespeare, topical at the moment, the rest is silence. I don't want to end on that because it's slightly depressing, so just the last couple of slides. Is there a way out of this fate? Well, the multiverse is again a hypothesis. In the early stages of the universe, there was a period of massive inflation, not the inflation that now is 4.6%, a different sort of inflation, where the universe expanded very, very rapidly, and parts of it became disconnected in terms of light communication. And it's possible at that point, multiple universes, who knows how many, almost infinite number of universes could have been created. Many of these universes would not be the same as our universe because the physical parameters could be different. So if you believe in the anthropic principle, and that is the universe is tuned with various parameters so that stars are formed, and if these parameters were different, stars would not form, planets would not form, and we would not form. So is there any meaning, and here's a philosophical question, is there any meaning to a universe without life to exist? Which is a version of God in the quad, I suppose. And I have no answer to that. But it's possible that these multiverses are here. But surely you will have noticed this. This doesn't solve the problem, does it? Because it kicks the can down the road. These multiverses eventually will suffer, in some sense, the same fate as our universe. So, okay, we can postpone the event, but it doesn't really prevent it. So, that's one possibility. And finally, another way out is if our universe, this is our universe now, if dark energy doesn't keep growing in strength as the universe expands, if we're wrong about that, there's some bit of physics we don't understand, or if the physical constants are not constant over time, like the velocity of light, which of course Einstein said is constant, and that's what we believe, one of the cores of physics, or the fine structure constant, the famous 1/137, which has to be pretty much as it is, otherwise stars don't form, galaxies don't form, we don't exist. If these are different and change, then perhaps we can escape that particular fate. Who knows? We should remember the famous quote, then, to finish, from a Nobel laureate. Cosmologists are often in error, but never in doubt. I think that's less true now, but it might have been when he said it. So, our universe, oblivion beckons. How long have we got left? Oops, sorry, that was a spoiler. Yes, that's how long we've got left, roughly. I'm not claiming that I've got the exact zeros right, but that's one of the scenarios. It is a hell of a long time. So I leave you with this thought. Meanwhile, feed the birds. And it is finally the end. A little bit over, maybe a few questions.
Yeah, thank you. I'm sure there are some questions prompted by that hour about 10 to the 100.
Compressed.
Hey Martin, thanks very much. So you started off the talk by saying that your predecessor, Temple
Chevallier, as in Cavalier.
Yeah, I'm not going to try it. That he was happy with the scientific discoveries of the day as a religious man, and you mentioned Darwin. I wonder, from your reading of him, how happy you think he would be with the Big Rip?
I think, and of course I'm not the right, but David Wilkinson wrote an excellent article on this, but I will give a go at it, just from what I read. And certainly with the Darwin scenario, he did not mind that Darwin had come up with this idea. He didn't say Darwin was wrong. He just said this just needs to be studied in the context that he thought science was a gift from God. So whatever science said, by definition, was related to God. And it was just a matter of putting it within the framework of the Creator. So whenever new science emerges, I think he would probably take that same view. And I just wish David was here. I don't know whether Lucas has any thoughts. Yeah, I do recommend that article. Of course, he was a man of his time, so it's very difficult to say what he would have thought about modern things.
Any other questions?
Hi, yeah. I think the talk was really interesting. I wonder if you think we're getting back to the kind of these proof of divine powers with the fact that nature appears to look physicality in pretty much every part of physics. Do you think we're going to start seeing more Temple Chevallier books?
Well, I think, there's a whole industry, of course, in linking religion with science, and I didn't want to go there in terms of can you interpret the scriptures in terms of modern cosmology and so on. I deliberately didn't want to go there. I think the mysticism certainly is rife. There are many books that I think, I'm not going to name them actually, but are basically pseudoscience. They just sort of try to link science with mysticism. I don't think that's particularly helpful. Some may be interesting, some not so. But will there be more people like... I don't think there will be more particularly like him because he was a man of his time. Clearly he was very religious, obviously. So everything he did was in the context of the Creator. And there's still ongoing debates, of course, and always will be, on whether there's a conflict between science and religion. I don't know whether there are many people in the audience. There will be some who are experts on this. I know David Wilkinson, to mention his name again, was certainly an expert and had many views on how there was not a conflict between the two.
One last question? Yeah, at the back, please.
Hi, I'm not an expert in it at all, but have you heard of the concept that in the event of a big rip scenario, since it's basically impossible to separate quarks, since by doing so you create enough energy to create a new quark, that perhaps in the case of a big rip, if the dark energy increases to a point where it's ripping quarks away from each other, perhaps each individual particle might be the seed of a new universe. Have you?
No, I haven't, but I would say this, and that is in the same way that we do not understand properly at all what happened in t equals 0 plus an infinitesimal amount, where all the laws of physics were one and everything was just very, very different and things became the laws of physics. Since we don't understand that, I'm sure it's possible that at the end of the universe, which we certainly have no way of observing, only to modelling, that it's possible then that there are other forces become active that counteract the Great Rip, the dark energy, quite possibly. It's pure speculation. I think the difficulty is that as scientists we like to be able to test something, even if it's only a prediction from a computer, using our current theories. Of course we can never actually go there, but we can say under our best ideas of physics, this is what we think will happen. So I think that idea, which I was not particularly familiar with, does raise questions about towards the end of the universe, all bets are off, which is why I mentioned some of the other scenarios for changing the physical constants. And your mention of this other idea would be in that kind of category, I think.
Thank you. So, at that point, I think we will wander off with great thoughts and realisation that we probably have enough time to think about it. So let's all thank Martin.